Hello and welcome. Today we're gonna work on something different. I'm gonna show something that I created for my teaching with my students. It's a piece of software that I use to create exams and tests for my JavaScript students, and I created it to because I don't like paper. I don't like to use paper for testing and evaluating my students. So I needed to create something that works online. And then I wanted to make the evaluation process faster. So I didn't want to check all the code that my students created manually one by one, because I have 75 students, okay? So initially I wanted to create like small questionnaires, like in which students would have to pick a solution within a list of 4 different solutions. That's what we call a QCM in French, which is multiple choice questions. This is good enough when you for beginner courses, like at the beginning when we started learning about types and variables and stuff like that. But as soon as the students started to code, to actually write code, this was less effective. I wanted them to write code and to find an efficient way for me to evaluate the quality of that code. And because I didn't want to do it by hand, I decided to create a program that would evaluate automatically the student's code by running automated tests on it, like if it was an application with unit tests, you know. And the output of an exam will be a list of grades. Like each student would have a grade on 5 points or 20 points, depending on the size of the exam. And most of the work would be done automatically by a script. The only thing that I would do then is to review the output of the script to see what each student got right and what each student got wrong, and then write something personal to say, okay, you should improve on this, or this was wrong before, or maybe you should reread that part of the course, etc., etc. Okay? So now I'm going to show you how this works. The project is called JS exam, like examination. But of course you can use it in a day-to-day basis for training, for example. It's a very versatile tool. I've been developing it for almost a year now. So let me show you how it works first, okay? So of course it's an NPM project, because I did it using node.js. So it's made of a simple HTTP server without any smart things whatsoever. And this server delivers a Polymer application. So it's a web component-based web app. And then on top of that, I get a bunch of Node.js scripts that are able to get the data from the students and evaluate it to turn it into grades. And as a backend I'm using Firebase, because it makes it easier for me to deploy a new instance every time I want to start an exam for my students. And you know, I don't have anything to deal with. Like I don't have to manage a database or anything like that. Everything is taken care of by Firebase. So as you can see in my npm script here, I got several commands. The first one is to build, because as you get from the title, my exercises are defined in Markdown, the same language that is used on GitHub, for example. So we need to turn these files into some executable exam, okay? So that's what this script is going to do. The eval script, you use it when you want to evaluate the students. So it will get the students' reply from the Firebase backend, and then run automated tests on every solution to make sure to evaluate the grade of every student, okay? And then I did several alternative versions from that. because in some cases I wanted to download the students' replies into a JSON file locally and then run the tests many times on the same files without having to connect to Firebase servers every time, okay? But basically it's working the same, it's just using another source for the students' replies. Then I have a screen to deploy it to Firebase hosting, which is one way of getting it online, and another one to deploy it to Heroku, because it doesn't really matter if you want to upload it to Firebase hosting or Heroku, because as I said earlier, it's a very simple HTTP server. All the files are static because they're generated by the build command here, okay? And this script was made to deploy several instances because I have 3 classes of students, and sometimes I want to run the same exam for the 3 classes of students. So this will deploy to 3 different Heroku's accounts. Okay. So that's it for now. What I'm going to do is show you how it looks like. Okay. So now I'm going to start like a typical node.js application. npm start. This will start a web server provided by Firebase, and or maybe not Firebase, but it doesn't really matter. As you can see, it's running a script from the public directory, and it's open on the port 8080. So let's see how it looks. So, sorry for the text that is in French, because my students are French. It's a French course, but it doesn't really matter right now. This is what a student gets after logging in. You know, as you can see, there is a Google sign-in button. It's because my students or my school is using Google Apps or Google School, I don't know how it's called, to identify the students. So every student has a Google account from the domain of my school, basically. Okay. So as soon as they log in, I know what student is getting logged in. So I know his name, email address, etc. So it gives me the opportunity to filter and to make sure that everybody found a way to connect, and of course to know who replied what to every question. Here you can see that it's in French, but it's saying that this copy was already submitted, so I cannot edit my replies, okay? But it doesn't matter right now. What I want to do is show you how it looks. As you can see on the top, you see the name of the students. So in that case, it's gonna be me and the Google sign-in button. And then right below, you get a section of the test, which is called QCM for multiple choice questions. And you get several questions here. As you can see, one good reason to use Markdown and to make my own implementation is that I can print some nicely colored code here, you know. So this is normal text and this is HTML colored text. And then you get the actual questions with the actual choices that I designed in Markdown. And what you can see here is the explanation of what is the right answer. This is what you get when you submit your copy. Okay, so a first question, second question, third, fourth, and then you get another section here, which are coding exercises. So same way as the multiple choice questions, you get like nice Markdown rendering, and then the students are invited to type in their code here and then submit. Okay, and as soon as you do that, you get the solution that was expected on this. But most importantly, your solution is going to be evaluated. Let me show you an example of what I already published for my students to train. So it's going to take a few seconds to fire up. So this was used to train my students before the first actual exam. So it's like I thought it was bigger than that. Let me refresh. Okay, So this is a cool example because this displays how the automatic evaluation works, okay? So in that first question, I asked my students to create a sum function that returns the sum of the numbers that were passed as parameters, okay? So here I give a sample function call with the expected output, okay? So here, if I do it right, I'm gonna do something like that. And we want 3 numbers, so I'm gonna call them ABC. And what I want this function to do is to just return A plus B plus C. Okay, this seems to be a correct implementation, you know. And now, if I do the second exercise, what I do, like, I would create the function, but not make it do anything. So it's a correct implementation, but it doesn't do anything, okay? And I'm gonna submit my copy. And this is what the students will get, okay? Will get a grade. This was a total of 9 points, and the student got 4 points only, because this exercise was correct, so he gets all the points. So basically 1 point per unit test that passed, because my implementation is correct, so I got all the 3 points. On the second question, I got only 1 point, probably because I showed that I was able to create a function, which already deserves 1 point, but the unit tests that were used to try that my function works for every case didn't give me any points, because my function doesn't do anything, okay? And of course, I didn't reply to the last question, so I'm getting 0 points here. So that's what my students get for training themselves with coding. And so far it's not explaining what is wrong with their code, but it's giving them a few points and they can retry it to train and try to get closer to the solution. So now let me show you how it actually works. So basically there is an exam data directory here, a folder, with a bunch of MD files. And the first one is called exercise1.quiz.template.md. And as you can see, the questions that we saw earlier on my local instance are designed here in Markdown. So let me, okay. So here we got some nice HTML formatting. And the questions, the options for the multiple choice questions are given using hyphens, and the correct answer is provided by a star. As you know, in Markdown formatting, at least for the format that's used on GitHub, you can use hyphens or stars the same way. It's gonna create bullet points, okay, for every item. So here I use that flexibility of the Markdown language to give myself a way to tell the software which is the expected answer to that question. So when the expected answer is written, I put a star instead of the hyphen, okay? And for the other answer, I put a dash. And as you can guess, the students don't have access to that, right? When it's displaying on the web app, you only see the choices, and this, the fact that you select the right answer here, will be used in the evaluation part, okay? And what we get after the 3 question marks is a bunch of explanations of why this is the right answer, okay? So this is freeform Markdown. You can put whatever you want here, and it will only display after the students submit. So that's it. You know, like for each question, you have to separate them with 3 dashes, and then you put your questions text and the 3 question marks if you want to provide explanations. That's it. This is for multiple choices questions. Now for the code questions, it's kind of the same model, meaning that you can write your Markdown formatting for the actual question, and then you have the 3 question marks to separate the question from the solution, right? And when you get into that solution part, you provide the actual solution text that's going to show up in the web app. And then if you put 2 dashes, it will provide the second part of the solution, which is the JavaScript code that will be run by the evaluator to grade the students based on the code that he or she wrote for that exercise. Okay. So as you can see here, in that case, this was an exercise where I asked my students to basically define an on-click handler on the button, okay, to add a hidden class on that button. So in order to make sure that they wrote the right code, first I wrote the code that I expected from them, so the solution, and then I wrote an evaluation function. And this evaluation function basically fakes the DOM of the page by creating a button element that contains an on-click handler and a class list property that will be used to test whether or not the students found the way to add a class to my button, as it was asked by the exercise. And then the document element that is part of the DOM as well, with the getElementById function. This is a very simple implementation, just to make sure that the students found the way to use that function with the right ID. And as you can see, if they do provide the right ID, it's gonna give them a reference to the button element. Okay? Otherwise, it's gonna give back null. So it will cause an error. And then you see here there's a call to a function called underscore run student code. And this will be replaced by the actual student's code. Okay? So if the students get the same answer as me, that's the code that will be pasted there. Okay? So it will basically attach the on-click handler to the button. Okay? And after executing the student's code, these are the tests that are going to be executed. Okay? So first I'm creating a test array, which is empty at the beginning, and then I progressively push test results into the array. Okay? The first test is to make sure that they didn't add the class right at the beginning, because I test that my array here is still empty. And the only way to grow that array is whenever the students added a class to the button. Okay, so here I want to make sure that the class is going to be added only after the user clicks on the button that the students created the onClick function for. So that's the first test. If they didn't add the class right away, they get 1 point. Okay. Then there's a set timeout for 50 milliseconds that will simulate a click on the button. So it's going to call the onClick function on the button. So hopefully the student's code, the student handler is going to be run at that point, and should be calling the getElementById and button.onClick handler, and the onClick handler must normally call the button.class list. Sorry. So if they do it right, this will push an item into that array. Okay, so now I'm testing that the array is of length 1, and the class that was added to that button was hidden. So if they do that right, they again get 1 point. And then there's a third test 50 milliseconds later that re-clicks again on the button to make sure that it's still calling the class list add function. So normally the array should grow one more item that also has the value of hidden. If it does, I'm calling a function here that basically says to the code evaluator, or to the unit test runner, that which tests worked or passed, or which test fails. Okay, so it passes the array of test results here, and based on that, the evaluator is going to give a grade to the student for that exercise. And obviously then it's going to make a sum of all the grade of all the exercise to get the total grade. So that's how I make the exercise. Okay, basically. So let me give you an example. I'm going to create a new function here. That's going to be a very simple function, very simple exercise. What's the result of 1 plus 1? Okay. And I'm going to provide several answers. I'm going to provide 1, 2, 3, and 4. That's it. And then I'm going to provide a solution, an explanation of the solution, sorry. I'm going to say the answer is 2. Check with your calculator. And because I don't want to merge the two questions, I have to separate them with a triple dash, okay? So if I refresh my page here, nothing changed, okay? It's still the previous question. Why? Because I didn't generate, I need to regenerate the file, okay? So in order to do that, I can restart the server, and it's gonna run the build command for me. As you can see here, run build, okay, build exercises, parsing, generating exam.data.js, okay? So now if I restart this, I get my new questions, okay? There's also another file that is very useful to create tests. It's the exam.config.js file. This is the configuration of the exam, as you can guess. So here you just give a title to the window, as it displayed on the top and in the title here. And then you can select a public test mode, meaning that students don't need to connect with a Google account. So I'm going to set that to true. And I can select whether or not I want to display the solutions after submit. Usually when I do a real exam, I turn that option to false, okay? There's also an option to redirect to HTTPS, which is useful, especially when you log in using Google, to make sure that we're using the same URL in a secure mode. But first, as I just set that to true, we're going to restart the server here and make sure that we can use the exercise without being logged in. So first I'm going to sign out and then refresh. As you can see here, now I'm a demo user with a weird number here. I'm number 49. Why am I giving a random number like this? The reason is simple. I didn't introduce it yet, but this piece of software allows to submit different variants for every coding exercise. Because my fear was that students would find a way to send the answers to each other, and so maybe they won't understand anything and we just copy and paste replies to each other. So in order to make sure that it's a real evaluation, a real individual evaluation, I wanted to prevent that. And in order to prevent that, I made like minor changes in the text of the exercise, depending on the ID of the student, okay? So basically I'm doing a modulo operation on the student's ID, and depending on the solution of that modulo, I'm gonna use one variant or the other, okay? But we'll see that later. First, what I want to show you is how you actually reply to a question. As you can see here, whenever I click on one option, there's a little loader animation there. This means that the solution is getting uploaded to Firebase, okay? The good thing about that is that if I refresh, I can see my replies. The students' replies are reloaded from Firebase. It's very practical because sometimes the student's browser may crash or for some reason, and they want to go back to their copy without having to retype anything, okay? So it's saving all the time to Firebase. Also, Firebase provides a nice functionality for free, is that even if the student is temporarily disconnected from the internet, it's going to cache all the replies and stuff in the local storage of the browser, meaning that they can even reconnect to that page without internet connection and still get the answer they already typed in, okay? So that's it for now. Now what I'm going to do is show you a second type of exercise. I see that Jacob and Patrick joined the room. Hi to you too. Don't hesitate if you have any questions or any part that you want to see in particular. Okay. Otherwise, I will just keep going and show you progressively the features of that piece of software. Okay. One thing I wanted to show you is the way to use the variants. Okay. So in the previous part, we created a multiple choice question. So that was very simple. Oh, by the way, I didn't. We need to provide the answer here. Okay. Let's check something. I want to remove this because there's something I didn't show you yet. So you agree that earlier I showed you that I had already submitted a few responses to my test. So now I want to show you the evaluation part. So if I run npm run eval, it's gonna extract the data from Firebase. And for every user, every student, it's showing me the answers. Look, for example, this was my previous publication, and for every quiz answer, it's telling me how many points I got. Okay, so basically here I got 4 points out of 5 out of 4 to the quiz test. Then in the code evaluation part, it's displaying the code that I had typed in for that exercise. So this was the exercise about the button and adding a hidden class. As you can see here, I did a very naive implementation without the onClick handler, so I'm only getting 1 point out of 3 here, okay, for the code exercise, which means I get a total grade of 5 out of 7. So basically, when I want to give my grades back to my students, I just copy and paste this and put it back to Google Classroom. And that's it, they get the grade. Sometimes I add a few notes, a few annotations to explain what they did wrong, what they need to work on, and stuff like that. Okay. Now there's another nice feature I want to show you. It's the variance, how it works. Okay. So basically, what I wanted with variance is to have, let's say that we want an exercise that say, okay, write a JS instruction that displays the result of 1 plus 1 in the console. Okay? So, as you can guess, the solution here will be something like that. Console.log 1 plus 1. That's it. Okay? But as you can see, this is a very simple solution. So if every student has the same exercise, it's very easy to copy and paste this and get a very high grade without understanding anything about JavaScript. So what I did is to try to trick some things. Like for example here, instead of 1, I'm gonna say number 1. Okay. So basically, I'm creating a parameter here, and then I'm gonna explain a few variants. For example, number 1, in one case, is going to have a value of 1, and in another case, is going to be a value of 2. As you can see, I'm reusing the same way to provide the different choices in multiple choice questions that we used earlier on, except here is every option is a JSON object that contains the value, a possible value for that variable, and this will depend on the ID of the student. Okay, so I'll give you an example. Okay, so let's restart our server. It's going to regenerate the exam. Oh, sorry, I did something wrong here. Okay, for some reason it's not liking. Maybe I don't need to provide that actually. Okay, it's because I always provide automated tests, so it's kind of expecting that I provide a test here. So what I'm gonna do is just fake the presence of a test. Okay, let's restart again. So this time it's working, okay? So let's go back to our interface here. I'm still using the public mode, so I don't need to log in, and it's gonna give me a random ID every time, okay? So here, let's go to the coding exercises. I see that I'm getting the 1 plus 1, okay? For ID 908, if I refresh, this time I'm getting an odd ID, okay? It's not a multiple of 2. And see what we got. In the place of 1, I'm getting a 2 now. So we switch to another variant. So typically we just saw like two different rendering of the same coding exam seen by two different students based on their user student ID. Okay. So now what I'm going to do is show you how to provide a solution that depends on the variant. It's pretty easy. It's the same way. So you use a mustache-like variable here. So let's see. Oh, I need to regenerate again. Sorry. Yeah. So I'm a odd user ID. Okay. 841. And if I go there, so I'm getting a 2 plus 1, and if I submit, I'm getting the solution 2 plus 1, okay? If I refresh, this time I'm not odd, I'm even number, I'm number 10. I'm getting the 1 plus 1 here. And if I give my copy back, if I submit, I'm getting the 1 plus 1 solution. So as you can see, the solution really depends on the variant that was chosen for that user ID. I'm seeing some messages here, Patrick. So this web app is what you can use for exams. Yes, exactly. Thanks for saying it looks cool. Today, no, there is no drag and drop option so far. The only type of exercise I implemented here are multiple choice questions like this. So you just click on your choice. And coding questions, where you type in code and it's going to be evaluated automatically. So now I'm going to work to show you how to create automatic evaluation. Oops. Okay. Let's restart that. Okay. So now I provided a solution, but I didn't provide any way to test the code. So what I'm going to do is what I want to make sure is that the student is going to call that function with the right number in parameter, okay? So I'm going to create a console object because it doesn't exist in the evaluation context that contains a log method. And that log method is going to take one parameter, and I'm going to check that. Let's create a test array, and I'm going to test whether or not this is correct. Okay, so test is going to be I'm going to push a 0 or 1 depending on the number of points that the students got. If the parameter is equal to the sum of number 1 plus 1, he's going to get the points. Otherwise, he's going to get nothing. Okay. Then I'm going to execute the student's code. And normally, when executing that code, the student's code must contain some call to console log, right? So it's going to call my function here and increment the test here, okay? And as soon as we're done, I need to call back this function with my test array, okay, to let the evaluation software know how many points the students got for that exercise. So let's see if it works. Let's restart the server and regenerate the exercise data. So, and when we refresh the page, we're an odd number, so we're going to get the variant with the 2 here, okay? So, if I do nothing, if I just provide like bullshit like this, and I give the copy back, I'm gonna get no points at all, because my solution doesn't work, okay? I'm gonna open it, because I think I had some console log traces here. No, not even. Okay. So now let's try another thing. I'm gonna call console.log with 0. Let's give that. I'm still getting 0 points, okay? And now, if I provide the right value, 2 plus 1, hopefully... Okay, this is not working. Okay. Let me see, maybe I got something wrong with the variance here. Let me see, because I had another version. I don't really remember how I used to do that. So usually I'm keeping track of all the exercises I give to my students. Okay. So getting back in the past, see what I had given to my students. Okay, so evaluation code here. I don't know why this is not working, to be honest. Let's run eval to see what's going on. So, code evaluation, code 5, code 6. So here, I see that my answer got received by the Firebase, okay, by the backend, but for some reason I didn't get the score that I expected, code score, or it wasn't showing for some reason, okay. Okay, I think I know why. Okay, that brings me to another topic. In the configuration file for this exam, you see that there is a backend option, and this can be used to switch from one backend to another. So far I'm using a Firebase backend, meaning that all the questions are gonna be sent to Firebase, and that's it. You know, like the user is just gonna see the solutions, but no grading. Okay, the solutions are not graded right now. I'm gonna be grading them as a teacher later on. You know, like during the evening or the day after or something like that. If you want to provide like a real-time evaluation for students, you can actually replace the Firebase backend by the real-time eval backend. This is going to load another script that behaves differently. So let me show you. I'm going to regenerate our exam data. Now back to the test. So this time, my answers are not going to be stored in Firebase, right? They're just going to be kept as local state in my web app. And the cool thing with that backend is that whenever I select an option, I see how many points I'm getting for that solution right away. So this is pretty simple to do with multiple questions, exercises like these ones. But it's less obvious for questions like these ones, right? So let's say that, no, it's not a function. I'm doing a console log 1, for example. I need to exit of that box to see the results. I'm getting 0 points, okay? If I'm doing 2 plus 1, I'm thinking out. This time I'm getting 3 points. See? So it means that that code was evaluated in real time, or in near real time, let's say, by the browser. For that I used a component called jailed, which is a JavaScript, how do you call it, interpreter that is going to read the code and run it in a sandbox so that the students cannot like mess with the website or whatever, okay? And it's getting the points, the test array containing the points back to the real-time eval backend, which in turn provide the points and reactively shows them in my Polymer application here, okay? So at that point, I think I showed you most of the information here. I don't know what could be interesting for you. Maybe you want to see how the Polymer application is actually coded. So I'm gonna open. Basically, it's just one file. It's one index file with the basic usual meta description tags at the top. It's running a CSS file here, web components light, a file called elements.html that contains all my web components. Of course, then the Firebase dependency and the jail dependency that is used to evaluate the scripts. Okay, and then what you get here is a typical body, except it's using Polymer templates. Okay, so here I'm using a auto-binding body for the app, and this contains like typical material design, paper dialogue, and stuff like that. And most of the logic is done by using a template DOM if, depending on the state of the app. If I'm logged in, it's gonna show bonjour, which means hello. If I'm not logged in, it's gonna show connection, and then some invite that you specify in a Markdown file. So the user has to log in to actually interact with the exam software. And then everything is reactive, you see. I'm getting a bunch of variables here that are defined in my main app.js file as app.properties here. So basically I'm getting something active or that can be true or false. And the good thing about that is that I can use Firebase to shut down an exam whenever I want, because this variable is bound to a Firebase value, and whenever I update that value in Firebase, it's gonna just disable the test. Okay, so it's very handy when you want to make sure that your students can't edit the answers after a certain time, or you don't want to make the questions available before a certain time. Okay. Same for login here and user. Obviously, these values are going to be populated as soon as the student logs in. Here, there are interesting properties here that are very practical. As you may know, if you did some Polymer development, the if template is not very practical because you cannot create very complex conditions here. You cannot like combine conditions with the AND or operators, but you cannot run functions here. You cannot use arrays here, so it's pretty limited. Okay, and there is one workaround to do that, is to use like I did here, functions that are going to be evaluated reactively. Okay. For example, here the solutions are going to be displayed whenever this function returns true. Okay. As you can see here, I'm passing a parameter that is called myAnswers because I want to, because myAnswers is the object that contains whether or not the student has submitted his replies. And I only want to display the solution as soon as the student has submitted the replies, okay? So I add this variable here because it's a dependency of reactivity, meaning that whenever that variable is going to change its value, it will force the Polymer engine to recall that function and reevaluate whether or not they have to display that template. Okay. So basically here is taking the myAnswer reference, is checking if the copy was submitted or not, and if it's submitted and that we activated that parameter, display solutions after submit, it's gonna display the solutions. It's as simple as that, okay? And this, yeah, as you can see, is not a lot of code to make that application work. I mean, in terms of JavaScript code, it's nothing really impressive, okay? But then, of course, I get like different files for every kind of backend that I'm using, depending on what the user selected before deploying the exam, okay? So for example, here in the Firebase file, it's a little bit more complicated. Like, for example, it defines the behavior of the app when the student clicks on the submit button. It binds the answer to the backend, meaning that every time the app tries to figure out what is the choice to be selected, it's gonna read that into the Firebase database. And every time I select a new choice or option, it's gonna update that to the Firebase backend. Okay. So yeah, that's about it. It's a little bit more complex because there's some binding to do, but at that point it's mostly not UI based, it's pure logic. Okay. And for the real-time evaluation, okay, I defined a few helpers here, like how to make a sum, because I use it a lot in map functions. But basically what it does is the same way I'm binding the student's reply from the Firebase backend file, I'm doing the same way here. I'm using a onChange handler, and whenever a student answers something different, I'm going to run that evaluate answer function here, which will run another function called compute student scores. And compute student scores is gonna, depending on the type of exercise, is it a quiz or not a quiz, is gonna run that, which runs a code evaluator that again is stored in another file. Okay, and this does all the logic. You can recognize here the run student code. So this is basically instantiating a jailed sandbox, put the code in it, run the automated test, and get the grade back to display it on screen, okay? By populating an object that is called maybe score. I don't remember how it, oh, this, okay. For each question, you're getting a question number underscore points that gets the grade, and whenever this changes, Polymer is going to refresh the page with the points the student gets on every question. So that's about it. I don't know if you're interested to see one part in particular, or if you have any questions about this. So far, this software is partially open source, meaning that I started working on this last year, and this project was called at that time JS exam. So this is still open source. but it was less modular, meaning that there was no automatic evaluation and stuff like that. There was only one backend file. So, but you know, it's still functional, open source. You can use it if you want and play with it. Okay. And then I forked this into another repository, which is private, so you can't access it right now because I'm not decided yet what I'm going to do with it. Maybe if I find out that it has some value, I can either exploit it to create a service, like a online course with automated exercises and stuff like that, or maybe I could license it. I'm not sure what I can do with that, okay? But so far I prefer to keep it for myself and see what I can do it to create income. What am I gonna say? Let's check if you guys have any comments or questions. Hi Xeod. My stack is Polymer for creating the web app with reactivity. I think I'm using version 2, if I'm not or 1.2, I don't remember, to be honest. Let's see the package.json. Oh no, it's in Bower. Yeah, no, I'm using version 1.4 of Polymer, okay? I'm using Bower for the front-end dependencies, and I'm using, of course, node.js and npm for the backend dependencies, like for running the scripts, my teacher scripts. As you can see here, on the front end, there's not much things. Like async is very useful to run tests one by one because it's asynchronous. Google API to log in. Polymer cookie to keep a cookie. I don't remember why I did that actually, but okay. 0MD is a component to display Markdown data on the screen. Page, I believe, is to handle the scrolling. Paper elements are the material design elements provided by Google. And jailed is the JavaScript interpreter, like the sandbox interpreter that I use for real-time evaluation in the browser. Okay, so that's it for the front end. It's pretty basic. Okay, and for the back end, I'm getting quite the same dependencies here, except I'm using Mustache for the templating, for the rendering of my exercises, using variables and variants and stuff like that. Node static to create a web server, which is not really needed because Firebase provides one as well for local execution. Jailed, again, Firebase tools to upload to Firebase. Power async. Yeah, I think that's it. So if you don't have any questions, I think I'm gonna close that live coding session. Thanks, Xeod. And if you want to see my next live coding session, I invite you to vote. I created a page here that brings you to a survey, so you can vote for the next presentation. Okay? Vote for next session. No, I've not heard of Adonis.js. I don't know what it is, but I'm happy to read an example if you have one to provide, Xeod. That's it. Okay. Thank you very much for watching. I hope to see you again next time. Don't forget to vote on the live coding URL that I just shared in the chat, adrianjoly.com/livecoding. You can also propose your own topics if you want, although it's not sure that I'm going to stream something I'm not interested about, but you can still try. And I hope you have a great day and see you soon. Bye bye.